Now that we've looked at static systems, it's time to start looking at systems that are moving. And so we can look at, the first thing we'll look at is linear constrained motion. So for this unit, there's really only one thing we have to worry about. So we'll have some object or collection of objects, and we'll look at each one and we'll see what the forces are on it. So we'll have, force 1 acting on it, force 2, maybe force 3 is acting toward it, force 4. Okay, and we'll do just like we did in the static situation, where we say that F net is equal to F1 plus F2 plus F3 plus F4 and any other forces acting on it. The difference is now we're going to say that the forces might not add up to 0. So instead we'll have the mass of the object, if this has a mass of m, times its acceleration. And so now we can use the sum of the forces to find out how the object is moving. So this is really the first concept that you'll need in this unit. The second concept is just that the frictional force, the maximum static frictional force, is mu times the normal force. In general, the frictional force is going to be less than or equal to this. And the kinetic friction force is going to be equal to mu kinetic times the normal force, in magnitude anyway. So the thing is, this is all you need for this chapter. These two ideas. So every single problem that I give you is basically going to break down to taking each object, writing all the forces on it, adding them up, and then finding out what the acceleration of the system is. And so if we combine that with the two formulas that we have for friction, both static and kinetic, that's all we're going to need. Okay? But, it's not always going to look like that. Okay? So for example, we could take someone like Superman, and then basically what I'm doing with these problems is I'm putting glasses on him. And a lot of you are going to look at it and you're going to say, oh, that's not Superman, that's Clark Kent. And you're going to get very confused by the problems that we're doing, because they're not going to look anything like this, right? They're going to look much more complicated. But in the end, if you take each individual object, if you write all the forces on it and sum them together, that's going to tell you everything you need to know. So just doing these diagrams, it's the reason that Unit 11 was just drawing free body diagrams. Because if you can draw all the forces on a single object, then you can do any problem that I can give you that has to do with objects that are connected in some way, or coupled, or being pushed or dragged or falling, or anything else. Like, this is the entire unit. So don't let yourself get too wrapped up in looking at a problem and thinking that it looks completely and totally confusing, because in the end, all you're going to do for every single problem is just sum up the forces, just like this, and find out where the net motion is.